Assalamu alaikum. I am Abida and today we are going to discuss qualitative and quantitative analysis under the course of Analytical Chemistry 1 Chem 408. This course is for BS Chemistry 4th semester session 2018 to 22. As we have discussed in the previous lecture, the discipline of analytical chemistry consists of qualitative analysis and quantitative analysis. What is qualitative analysis? It deals with the identification of elements, ions, or compounds present in a sample. Or we may be interested in whether only a given substance is present, that we are only interested to know about the presence of one substance in the sample. So in qualitative analysis, we will only deal with the identification, no matter how much of the quantity of that substance is present. While in case of quantitative analysis, we will deal with the determination of how much of one or more constituents is present. So this is more specific. Quantitative analysis, that first we will know how many ions, elements or compounds are present in a sample, and after their identification the next step is to measure their quantity. So quantitative analysis is more specific. The sample, it may be solid, liquid, gas or a mixture. So sample can be present in any phase. The presence of gunpowder, for example, residue on a hand, generally requires only qualitative knowledge, not of how much is there. For example, I have mentioned in the previous lecture that analytical chemistry plays a vital role in forensic analysis, and if we want to determine the gun shoot by a specific person, then we can take the sample of the residues on his hand, and then we can check with the different analytical techniques. So in this case we are only interested in the presence of the gunpowder, and that we are interested only with qualitative analysis and not with the quantitative analysis. The presence of even a minute residue on the hand of the person will prove that he or she is the guilty. While on the other hand, the price of coal will be determined by the presence of by the percent of undesired sulfur impurity present. So the percent of undesired sulfur impurity present in coal, it will decide its price. So we must be sure about the percent of undesired sulfur impurity, because the less the sulfur impurity, more will be the price of coal. So in this case we are not only interested in qualitative but also in quantitative analysis, that first we have to determine that sulfur is present. This is an aspect of the qualitative analysis, and secondly we have to determine that how much percent of sulfur impurity is there. So this will determine quantitative analysis. There are different tests by which we can perform qualitative analysis. Qualitative tests, they may be performed by selective chemical reactions or with the use of instrumentations. So we can use selective chemical reaction, or there are different instruments present by which we can perform qualitative test, which we will discuss in the next slides. By means of selective chemical reaction, for example, the formation of a white PPT when adding a solution of silver nitrate in dilute hydrochloric acid indicate the presence of a halide. So what will we do? We have a solution of silver nitrate, and to it if we add HCl, then there is the presence of there is the formation of silver chloride halide at once. and nitric acid will be formed. So this is a selective chemical reaction in which we can judge the presence of silver in the sample by the formation of this silver chloride white precipitate. So this is an example of selective chemical reaction which can be used for qualitative test for the presence of silver ions in the sample. Certain chemical reaction will produce colors to indicate the presence of class of organic compounds. For example, ketones. This will also come under the heading of selective chemical reactions. That ketone, which is a class of organic compound, this can be detected by the presence of colored compound in the sample by adding selective chemical reagents. Infrared spectra will give fingerprints of organic compounds or other functional groups. So this is with the use of a spectrophotometer, in which we use infrared source, and this actually infrared spectra, it produces fingerprints of organic compounds. By mean fingerprints, there is a region which is called fingerprinting region in infrared spectra, which is specific for each compound. We will discuss further in detail in the next lectures. What we will do, we can compare this fingerprint region of each compound, or the compound to be identified with the fingerprints of the other compound present in the lecture, present in the literature. And in this way we can compare the fingerprints of two compounds, and this will serve as identification of the specific sample, of the specific compound present in the sample. So in this way, these two chemical tests, these are the qualitative tests which are performed by selective chemical reactions, and in this example, with the help of spectrophotometer, that is with the use of instrumentation, we have performed the qualitative tests. There are two important terms, selective and specific. So we must be clear about these two terms, that what is selective and what is specific. So a selective reaction or test is the one that can occur with other substances but exhibits a degree of preference for the substance of interest. So it can react with many substances, but it exhibits a degree of preference for the substance of interest. But with one substance, it can give you better results. While a specific reaction or test is the one that occurs only with the substance of interest. So a specific reaction will react only with one substance, while in case of selective reaction, the substance will react with many substances, but it will exhibit a degree of preference for the substance of interest. While a specific reaction will be the reaction in which the substance of interest will react only with one substance. Unfortunately, very few reactions are truly specific, but there are many reactions which exhibit selectivity. So, in order to obtain a selectivity, there are a number of strategies. For example, sample preparation, which include extractions, precipitations, instrumentation. In case of instrumentation, we can use selective detectors, which can detect only the desired amount or the desired component of the sample. Target, annihilate, derivatization. So we can derivatize the compound which we want to analyze. We can derivatize this specific compound. For example, in this case, we can derivatize specific functional group. Derivatization, actually, this is an organic reaction. In the next lectures, we will study more in detail about it. Then we can also use chromatography, which separate the sample constituents. We will study in detail about chromatography in the next lectures. So all these are strategies which can produce selective reactions which will help in the first identification and then quantification of the substances under study. Then quantitative tests, how we can perform quantitative tests. For quantitative analysis, the typical sample composition will often be known. We know that blood contains glucose. So before performing quantitative test, we are always sure about the presence of components in a specific sample. That we know that blood contain glucose, and after that, if we want to determine the quantity of glucose in that blood sample, then we will conduct some quantitative test, or else the analyst will need to perform a qualitative test prior to performing the more difficult quantitative analysis. Again, so we must know uh, before performing quantitative test that which substances are present in the sample, and in many cases we are only interested in the presence of, that is, we are only interested in the qualitative analysis, but in few cases we are also interested in the quantitative analysis. For quantitative analysis, uh, we must first know that which substances are present, and after that, if we need their quantity as well, so we will perform then quantitative test. Modern chemical measurement system often exhibit sufficient selectivity that a quantitative measurement can also serve as a qualitative measurement. So this is the advantages of science. So if we have to determine the quantity, so the instrument can serve as a means to perform not only the qualitative but the quantitative measurement at the same time. However, simple qualitative tests are usually more rapid and less expensive than quantitative procedures. So as I have already mentioned, that qualitative tests are simple, they are rapid and less expensive than quantitative procedures. Qualitative analysis has historically been composed of two fields, inorganic and organic. So yes, you may have different courses on inorganic and organic, so you must have the history of inorganic and organic reactions before you go to the analytical lab in order to detect uh, the elements, ions or compounds which are present, and then in order to find their quantity you must have background knowledge from inorganic and organic chemistry, that how these reactions are going to proceed. Then we will compare qualitative versus quantitative. Uh, in comparing qualitative versus quantitative analysis, consider, for example, the sequence of analytical procedures followed in testing for banned substances at the Olympic Games. So after the end of this explanation, we will very well understand the difference between qualitative and quantitative analysis, and in this topic we will also discuss that which experimental techniques, whether these are chemical or physical, can be used to perform qualitative or quantitative analysis. So in Olympic Games, the list of prohibited substances includes about 500 different active constituents. They include stimulants, steroids, beta blockers, diuretics, narcotics, analgesics, local anesthetics, and sedatives. But for this, the key point is uh, some of these substances, these are detectable only as their metabolites. Many athletes must be tested rapidly and it is not practical to perform a detailed quantitative analysis on each. So, in all these substances, for the detection of all these substances, it is not possible to perform quantitative test for all these substances. So, what will doctors do? What will analysts do? They will test the athletes rapidly. First, they will actually test qualitatively only from the urine metabolites, right? From the urine metabolites, and then the doctor will decide that they will go for the quantitative test, or only the analytical test can serve their purpose. So there are three phases in the analysis: the fast screening phase, the identification phase, and possible quantification. So in the fast screening phase, urine samples are rapidly tested for the presence of classes of compounds that will differentiate them from normal samples. And for this purpose, the techniques used are aminoassays, gas chromatography coupled with mass spectrometry, liquid chromatography coupled with mass spectrometry. So you can see that for qualitative analysis, these are the techniques used. So samples will be collected rapidly and they will be analyzed by these techniques. So these techniques are used for qualitative analysis: gas chromatography coupled with mass spectrometry, liquid chromatography coupled with mass spectrometry. These are more complex techniques as compared with the aminoassays. The second phase is identification phase. That we have collected the samples, and then we have performed analysis by means of different techniques, and then the second phase is identification phase. About 5% of the samples may indicate the presence of unknown compounds that may or may not be prohibited but need to be identified. So actually we will have a, for example, normal urine sample. In the normal urine sample, the substances and the major component is urea, for example. So if the urine sample contain the unknown compounds, these unknown compounds, they may be allowed or they may be prohibited, but they need to be identified. Samples showing a suspicious profile during the screening undergo a new preparation cycle. So actually we will extract the compounds from the urine sample which have shown a suspicious profile, and then we will perform then the analyst will perform a new preparation cycle, and this will include the organic chemical reactions, including hydrolysis, extraction, and derivatization. So by means of these techniques, they will convert the suspicious compound into into another compound which can be detected easily by the qualitative by the analytical techniques. So depending on the nature of the compound they have been detected, analyst will decide that it will perform on that compound, on that suspicious compound, either hydrolysis in order to convert it into a compound which can be studied easily by, which can be detected or which can be quantified easily by analytical technique. Analyst can use hydrolysis or extraction and derivatization. So this will depend upon the nature of the compound which is suspicious in the sample. The compounds are then identified using the highly selective combination of gas chromatography, mass spectrometry. So in this technique, GC is coupled with mass spectrometry. Gas chromatography will separate the components of the mixture, and mass spectrometry will serve as a technique to identify the different compounds present in the sample by means of mass spectrometry. So this is a highly specific type of instrument in which gas chromatography is coupled with mass spectrometry. In this technique, complex mixtures are separated by gas chromatography, as I have already said, and they are then detected by mass spectrometry, which provides molecular structural data on the compounds. So actually, there is a library for the spectra obtained by means of mass spectrometry, which is which is present on the computer data. So we can actually computer will perform automatically these analysis, and it will compare the mass spectrometry data obtained from the instrument with the data of the compounds present in its library, and uh, after comparison it will give you the results once the analysis is performed. The MS data combined with the time of elution from the gas chromatograph provide a high probability of the presence of a given detected compound. So we will compare the mass spectrometric data with the time of elution from the gas chromatograph, and this will give us a high probability for the presence of given detected compound. GCMS is expensive and time consuming, and so it is used only when necessary. So up till now we have determined that which elements are present, and then we have determined about their nature, and with the help of GCMS we can also determine that the class of compound, and if for example by means of spectrometry in the library of the spectrometer, mass spectrometry, we can also be sure about the presence of a specific compound which is inhibited or which is prohibited if the spectra of the compound present in the urine sample, for example, matches with the compound present in the library. So we can be sure about the presence of the prohibited compound in the sample. The next step is the quantification, as in some of the cases substance is prohibited, for example under its high level only, that is, it is permitted in the low quantities but prohibited in the high quantities. So then we need to quantify it, as I have already mentioned that quantification need more time and it is much more expensive. So following the identification phase, some compounds must be precisely quantified since they may normally be present at low levels, for example from food, pharmaceutical preparations or endogenous steroids, and elevated levels must be confirmed. So as I have already said, that some of the substances they may be permitted at their lower concentration, and this lower concentration it may come from food, from pharmaceuticals or endogenous steroids, but their high levels are prohibited, so they must be quantified, and this is done by using qualitative techniques, quantitative techniques such as spectrometry or gas chromatography. So by means of spectrophotometry we can measure the concentration of a substance present in a mixture. We can use, for example, UV visible spectrophotometry, and then we can use gas chromatography, which is more specific as compared with UV visible spectrophotometry, again depending upon the substance we want to quantify, nature of the substance we want to quantify. We can use gas chromatography, that liquid chromatography or solid chromatography. So this is the last slide of today's lecture. and this will give you an overview of classification of techniques as qualitative and quantitative. Analytical techniques, as we have studied, they are divided into two groups: qualitative, in which we are concerned about the quality, that which element, ions or compounds are present, and quantitative, that what is the amount of these ions, elements or compounds in the specific sample. In order to perform qualitative analysis, there are two types of tests: chemical and physical. Chemical tests, they include hydrolysis, precipitation, derivatization, and immunoassays. Depending upon the components present in the sample, we may go for hydrolysis or precipitation, or we can convert um, a functional group into a more specific group which is easily detectable. We can use the process of derivatization, which can be used for the conversion of uh, non-specific, for example, functional group into a specific functional group which can be easily detected, and then we can use immunoassays. All these come under the heading of chemical analysis for the determination of quality of the substance present. Okay, so physical methods for qualitative analysis, they include UV visible spectrophotometry, infrared spectrometry, liquid chromatography coupled with mass spectrometry, gas chromatography coupled with mass spectrometry, high performance liquid chromatography, and then simply mass spectrometry. So all these are physical methods in which we use a specific instrumentation for the identification of components of the mixture. Then we will move towards the more complex quantitative analysis if we need it. Again, quantitative analysis can be done by means of chemical methods or by means of physical methods. Chemical method include titration. Titration may be acid-base titration, KMnO4 titrations, ethylene diamine, EDTA titration, ethylene diamine tetramine titrations, and then iodine titrations. Iodine, as you people know, iodometric titrations and ID-metric titrations, and amino acids. So actually we have to design a protocol in order to perform these chemical analysis for the determination of quantity of a specific substance present in the sample. Then there are physical methods which we can use for the determination or for the quantification of a specific substance present in the sample, and this again includes spectrophotometry, um, uh, which is UV visible spectrophotometry. We can use then chromatography. In chromatography, for the quantification, this include liquid chromatography, gas chromatography, and then more specifically we can also use high performance liquid chromatography for the quantification of different substances present in the compound. So you do not need to confuse that we can use for example the physical methods at the same time for qualitative and for quantitative analysis. Actually, the use of physical methods for the qualitative analysis is very simple, or you can say straightforward. But for quantification, as you can see that I have mentioned here, that we can use UV visible spectrophotometry for qualitative as well as for quantitative analysis. So for qualitative analysis, we have to stop our measurement until lambda max, that we will determine the lambda max of a specific substance, and then we will compare its value present in the literature, and then by comparison we can um, um, we um, uh, we can make a guess about the presence of a compound But for actually quantitative analysis, we have to design a protocol. So, and this is the case with all other techniques used for quantitative analysis. So we have to, for example, for HPLC, we have to design a protocol in order to, in order for the quantification of the substance present in different samples. In my PhD process, I have used UV visible spectrophotometry for the quantification of my drug substances present in my compound, and one of my colleague during my PhD, he has used HPLC, high performance liquid chromatography, for the quantification of his samples. So this is all about today's lecture, and we will inshallah meet with the next lecture. Thank you. Allah Hafiz.